Unmute the audio so we are live.
Okay.
So we're going to get started in about 2 minutes. This is Mike Shelby. Just hang on. Hopefully everybody can hear us. Make sure you crank your speakers up. We're only doing audio over the computer. All right.
Name a few times today. Talk about the co-ops Inundation Dashboard.
Yeah.
Smell over there.
Talking
Just
about
like it's a friendly thing. Yes. Yeah.
Yeah.
I'm friendly with my other first. Yeah. My husband please smell of fish.
Really?
Like if I want to eat fish, it has to be lunch. Or when he's out of town.
So just so you know, in here, the screen's only gonna be that big. So we can't maximize it because we lose that, so.
We are also very interested, and I reminded people to come because we're looking at this system.
Adobe Connect?
Yeah, this is Adobe Connect, so this, there we go. Information number one.
Just not gonna be maximized, so some of it might be a little tough to see. So guys,
And in Adobe Connect, it provides the text, is that correct? And also the recording?
Yes, so
Within?
the lower left corner here, we're connected with Caption Colorado. So we have Captioner online, listening through the audio,
You have a human being doing
human
that?
being doing it.
Oh, okay.
And yes, we're recording everything that includes the chat,
Mhm.
captioning, and the slides.
And your human being is part of the Adobe service or someone on your staff that you pay to do this?
No, that is a separate service that Department of Commerce pays for,
Fantastic.
video relay service. We're just able to use it. Anybody can use it in commerce.
Let me see how many people we have.
Yeah, let's see. Where's my mouse? 61 online. Awesome. Okay, so we should get started. Top of the hour. Hello, welcome to NOAA's National Ocean Service Science Seminar Series. The goal of this seminar is to communicate and discuss a variety of coastal and marine topics of interest to NOAA, the coastal and marine community, and anyone else who is interested. My name is Mike Shelby, and I'm hosting the seminar today for Tracy Gill. Tracy is away today. Before I introduce our seminar, here are a few logistics. The presenter, Billy Sweet, would prefer that you hold all questions to the end and use the chat box, which you see on the right-hand side of your screen. You can maximize the slides at any point in time in that slide pod using the little arrows, the 4 arrows on the top right. If you're interested in getting a PDF copy of the recording of today's presentation, please contact tracy.gill@noaa.gov and she'll be happy to send you a copy. And also, if you're not on the NOAA's weekly science seminar email list but would like to be, please email tracy.gill as well, and she will add you to the list. Folks in the room, please silence your phones. And with that, I will just introduce the seminar. Today it is titled the 2018 State of the U.S. High Tide Flooding with a 2019 Outlook. And our speaker today is Dr. William Sweet, an oceanographer with NOAA's National Ocean Service Center for Operational Oceanographic Products and Services, or CO-OPS. Billy is here presenting with me today at NOAA in Silver Spring, and here's a little background on him. Billy Sweet is a NOAA oceanographer researching and developing products about how sea level rise affects coastal flood risk. He helped the U.S. Department of Defense assess coastal flood risk across their global installations and was a lead author for the 4th U.S. National Climate Assessment. He enjoys sailing the Chesapeake Bay and teaching his kids about the signs of sea level rise from his home in Annapolis. Welcome, Billy. I'm going to turn it over to you, and thanks for coming today.
great, thank you, Mike. Glad to present today on our latest report, 2008 State of High Tide, U.S. High Tide Flooding with the 2018 2019 outlook. So pictures sometimes do justice more than words, and I think this is the type of talk that probably several different pictures could be cycled through each year. Many of you online or in the room probably have your own image or memories of flooding that occurred last year, whether it was from a storm or maybe it was sunny outside, but it's increasingly sort of the sunny day conditions that are starting to creep up in our communities, and this is sort of what the focus of today's talk will be on. Here.
Yes, those are ours. Yep.
So in support of NOAA's sea level rise science and services, what this report is doing, and it's the fifth in a series of reports over the last 5 years that really tries to use sort of societal impact thresholds to communicate the impacts of sea level rise. It maps regions at risk to flooding of high tide flooding. It looks to scorekeep event frequency so we can sort of put that into historical context and keep an important perspective of how things are changing. Part of that too is tracking trends and how they're changing through time, as well as give some sort of sense of seasonal guidance of when these types of events tend to happen throughout the year, as well as giving a next year sort of prediction or projection, if you will, as well as multi-decadal projections. And I think the real, the importance of this kind of work is that you can't just sort of do it and then walk away from it. You know, there really is no set baseline anymore with coastal flood risk and sea level rise. Every year, the risk is increasing and the flood counts keep rising. And it's something that really requires sort of that annual maintenance, if you will. There's sort of two types of planning that are going on across coastal communities. Sort of the long-term, sort of proactive planning, perhaps to minimize future risk due to sea level rise, both of the major events and the maybe the lesser extreme events. And there's also the reactive planning or response kind of responsiveness to flooding in the streets. Police working overtime to shut streets, pumps, sandbags. There's a cost associated with flooding and the future's here. And so this is why we're kind of providing this kind of annual update each year to help communities plan and prepare for next year. So here's just some other images. You know, I think the real thing to stress is sea level rise impacts are happening now. It's largely an East Coast issue, though there's Gulf Coast and West Coast areas and Pacific Islands that are feeling the effects of sea level rise, decades of sea level rise. But it's some of the most noticeable sort of impacts are, you know, flooding of streets, clogging of stormwater systems, folks taking different routes to work, to school. It's starting to become a serious issue in many towns. We recognize that sea level rise is only one of several factors that is increasing flood risk in communities, but it's definitely a dominant factor, and it's one of which where the signal is sort of really popping out from the noise. It's a very clear signal throughout the last several decades and projecting forward. But you know, in combination with heavier rains and storm river flows and increasing groundwater tables, there's a variety of factors that are causing flooding in communities. But again, we'll focus primarily on the sea level rise component. NOAA is working towards sort of providing forecasts of water from all these sources, and it's also recognized that, you know, probabilistic information of, you know, what is the likelihood of flooding in front of your door step or, you know, affecting your home or business really doesn't matter where the water is coming from, and ultimately that's where the science is heading in terms of, you know, recognizing that flooding occurs from multiple sources. But today we'll talk about tide gauge flooding as it's measured by tide gauges, or sea level rise flooding as measured by tide gauges. We're doing this again to be useful, sort of a use-inspired set of products and services that we work towards in the Ocean Service and throughout NOAA. And I guess what this schematic is really showing is it's, you know, the processes that occur in the ocean, causing variability at the coast in terms of time and length scales and magnitudes. And what's circled there really is a sort of ocean and atmospheric warming component of sea level rise. If that wasn't changing, then perhaps things would be more stationary and we wouldn't need to adjust through time our flood defenses. And so that change in sea level rise is really causing problems, let's say, in planning for longer term projects such as major flood protection projects that let's say the Army Corps of Engineers works on, infrastructure upgrades within communities. Annual response budgeting is increasing in areas like Norfolk and Charleston and Miami, shutting down streets, and as well as preparing and implementing. When do you actually spend your money or your capital to prepare for the upcoming flood season, let's say. So, for instance, just last year, and part of what we're doing in this report is also documenting some of the impacts. We may not be collecting them directly, but they're either written about in the media or in peer-reviewed journals and discussing the impacts. But just last year, there's reports and articles coming out talking about sea level rise and high tide flooding, clogging stormwater systems, flooding roadways, disrupting traffic, largely along the East Coast. I'm from Annapolis, Maryland, and there was a really interesting study talking about how it's interfering with parking and commerce and stores in downtown Annapolis. And we'll give some examples there in a moment. It's raising groundwater tables and degrading septic tank system functionalities in South Florida. That's kind of gross water, but that's sort of what happens when sea level creeps up and groundwaters creep up. Those types of systems no longer function correctly, as well as salting and farmlands within coastal Delaware and Maryland. Just that sort of laying waste to some of these areas that used to be productive are less productive. So the global sea level rise and local sea level rise, we measure it from many sources, the components of it. Sea level rise is currently rising about 1 inch every 8 years, measured by altimeter. But we know that it's not uniform, and it's also largely in response to vertical land motion. So at CO-OPS, we collect relative sea level rise at the tide gauges and make this known to the communities. But I think it's also important to recognize that the historic trends aren't necessarily the trends to plan by in the future. In this case, past isn't likely to recreate itself. It's going to be a different future, and that's important to recognize. And we'll give some examples of that here shortly. And discussing the impacts due to sea level rise, what we're trying to do is really marry up to weather impacts that folks actually feel and sense on a day-to-day basis. And in this case, we're really trying to align with what the National Weather Service weather forecasting offices have come up with in locations in conjunction with their emergency managers as to when water levels reach a certain level on the tide gauges through years of impact monitoring, certain types of responses or impacts are felt. They could be minor, and when that happens, the weather forecast offices typically will issue a coastal flood advisory. And if there are going to be more major or moderate or major flooding, non-tropical, and in response to non-tropical systems, they'll issue a coastal flood warning, really sort of more of a risk to life and property. But in all cases, it's these warning levels or advisory levels are what are actionable to people on a day-to-day basis. And we'll focus on the minor flood threshold that we're calling high tide flooding. We used to refer to it as nuisance flooding, and sometimes it's called sunny day flooding, but now we're using the term high tide flooding. And however, it's in order to communicate this across the country, seeing that we're a national entity, we had to come up with some ways to communicate impacts nationally. The Weather Service didn't have, forecasting offices don't have thresholds everywhere. And where they do have them, sometimes they vary in flood severity. I'm from Annapolis. The local advisory level there really is more of a stormwater infiltration level. It's not really very noticeable on the streets. But for instance, somewhere like Galveston or St. Petersburg, the water has to overcome a major hurricane storm wall. And so once it does that, it's not really minor at that point either. So what we did is we sort of did a best fit solution, that regression line there on the right, And that will be the level based on tide range around the country. We can more or less paint the shoreline then and come up with a sort of regional to national scale set of numbers that largely explain coastal vulnerabilities to sea level rise and high tide flooding around the country. And so on the left there is the actual map showing the elevations above mean high water. So somewhere in English units, somewhere between about 1 3/4 and 2 feet above average high tide is when water really starts to show itself in an apples to apple comparison among communities. It's not to say some communities might not flood before that level. For instance, Miami, they may flood with about 1 foot of water. But in this case, again, we're really trying to do this national sort of assessment. So for an example, sort of mixing locations here, there would, on the left would be New York City and the Statue of Liberty, but the right would be Annapolis. And giving an example of our tide gauges in this high tide flood threshold was an example from 2017, on October 24th, where we exceeded the level. And the image in the back is our community when the water's really reaches the fire pit. It's putting out the fire. It's actually over the finger piers there. We're actually in the process of replacing those piers that were damaged during Hurricane Isabel, and now they need to be replaced because they're going underwater too much. So on a local level, it's hard to get right. You want to live near the water, you want to access the water, but the water's moving, it's increasing, it's rising, and that's a problem. So, that might be somewhat, inconsequential in the grand scheme of things, but right downtown Annapolis, when that water reaches that level, then storefronts, water's up to the storefronts, and folks aren't actually shopping. They're not walking through water to go to the stores, and that was what one of these papers showed, is the amount of income that was lost. And that actually happened 12 times last year. It was a record, and we'll look at some other record-breaking areas. And so it really is now not just a local community, but it's these coastal cities, and it's happening up and down the East Coast. It's sea level rise. And so some of our other office in National Ocean Service has developed maps that are showing the amount of extent of land that is now at risk to flooding at high tide, at these high tide flooding. So it's not your normal high tide, but when it reaches that level, the threshold that we showed. So it's upwards of 2,700 square, I think, miles of coastline that's at risk. And it really encompasses a lot of the major coastal cities along the East Coast. A lot of these cities were built on fill 100, 200 years ago to get up close to the water to support more infrastructure along the coast. And it seemed like a great idea then, and it's still a great idea now. Folks love to live where they live, but it's these areas that are particularly prone to flooding, of stormwater infiltration, water coming up out of these systems into the roads. And you can see from the map, it really is these areas of large expanse of east and Gulf Coast areas, a little less so on the West Coast. And it's really, East Coast is heavily urbanized and a lot of people. It's sort of the same for the Gulf too, where it is urbanized, but let's say in Louisiana, you have a lot of undeveloped areas, or there is flood protection like in New Orleans. So a lot of the emphasis right now is on the East Coast, but I think in every one of these communities, there's likely stories of saying, we're flooding more often than we used to. And what we're trying to do is marry up the tide gauge statistics to sort of the community experience or the living history of an area that recognizes how flooding has changed. So in the scorekeeping aspect, last year, 2018, and this is a meteorological year from May to April, so May of 2018 to April of 2019. We're not splitting up the winter season for some predictive reasons. There was 12 locations that broke or tied their all-time record, and largely in these circled areas, sort of the Chesapeake Bay region and then the western side of Florida. Some of it was in response to some hurricane forcing, but some in the Chesapeake Bay is just due to wind forcing and sea level rise. But in all things, typically the less happens more than the large, and so typically is more weighted to the smaller events than the larger events. And we'll see that here in a moment. But every year we've done this report, there's always been 10 or more records broken, and this is to be expected next year and the years and decades to follow. As sea level rises, more and more towns are going to flood more often. In context, in our report last year, we put out a prediction for this past year. And what I think this plot is showing is that we're really keeping a good sliding baseline. 2/3 of the areas were within the range of predictions that we provided, whereas about 1/3 was above, and that's largely due to increases in sea level rise will cause large jumps in your flood frequency, and or you may have a particular stormy year, which is above sort of the climatological norm. Only 3 locations were below prediction, and they're shown in blue for some reasons. But more times than not, these types of outlooks are really sort of providing that baseline of what's likely to happen in most areas, and it could be more, but it's likely not less. We're keeping track and sort of scorekeeping in a new operational product that we've developed at CO-OPS called the Inundation Dashboard. Among other, it does several things, one of which will provide alerts as to the instantaneous flooding. Here's an example of Norfolk Sewell's Point. Now time as well as projections over the next several days. Are you likely to flood? It's not to replace what the Weather Service does. It's more just keeping track. And when you do flood, it'll add it up and tally over the course of a year so we can sort of operationally make sense of these events. And here's this same sort of plot I just showed how these events have been changing through time, accelerating, and we'll discuss more of that. And what isn't necessarily surprising, but it probably is if you are a citizen in these communities, since we have aligned our tide gauge thresholds to what the actual Weather Service's field offices actually communicate in terms of coastal flood advisories. What we see in the upper left is this sort of national median, which is representative of all the coastal weather forecasting offices along the country. They're really in pretty good agreement. The black is the high tide flood counts from the tide gauges, and in orange would be the actual advisory numbers per WFO, in this case the median. And then we'll give some examples from around the country. There were 7 NOAA Weather Forecast Offices in 2008 who issued record numbers of coastal flood advisories. And as in many of these locations on the East Coast, they're really growing in leaps and bounds on a year-to-year basis. So it's really this sort of weather meet climate, climate meet weather situation. Sea level rise and climate change is really playing out at the local level in terms of increased sort of tidal weather. And that's how community folks really get their information. It's similar to, are you bringing an umbrella today to work because it's raining? Well, in a lot of these communities, it's what route are you going to take to work, knowing that your roads are maybe impassable. And it's a situation in many communities now in the United States where that's the situation. So I think this is how these relationships are developed, through the trust and the dependency upon these weather forecasts to alert and to day-to-day activities. And this is the way it's playing out too with sea level rise. So moving forward, we're working with the Weather Service to sort of develop some actionable information to translate this changing in coastal flood risk in their forecasts and preparedness over an annual basis. Oh, that's a repeat. Okay. So when we are tracking these changes, we sort of score keep, and now let's see, how are these changes themselves occurring on a year-to-year basis? And here's a schematic that really sort of shows typically a probability distribution of the daily highest tide. So each one of those curves, the area under that curve would represent 365 days a year. For the most part, things sort of tend to be around a certain a range, let's say. So let's say in Norfolk, you're typically maybe within a meter or so. Most of your water levels tend to hit. There may be a hurricane that would be way out in the tail. They're very infrequent. We're really talking about the typical tides and typical weather. Now, due to sea level rise, are becoming increasingly likely, and relative to that high tide flood threshold, water in the streets, storm water is kind of clogged. People driving through water to get to their homes is really starting to get under that nonlinear part of that curve. And that's a problem as a citizen, because what that means here, let's say at Norfolk, is now on a year-to-year basis, the annual flood frequencies are accelerating. Doesn't matter if mean sea level is accelerating, impacts are accelerating. On the West Coast, they're increasing. It's really sort of El Nino driven. It's not as monotonically increasing sea level, so it's not a nice gradual increase. It's sort of punctuated. So statistically, they may be more of a linear fit, whereas on the East Coast, many of these areas are now quadratics, meaning that change is at hand and it's changing rapidly. By the time you notice water coming up out of these stormwater systems into your streets, the problem's going to get chronic rather quickly. It's not a slow, gradual change, and this is sea level rise. This is the way it's playing out. When we look again on a national basis, sort of this would be the median amount of sea level rise due to the ocean, not land motion. And this would be the median number of high tide flood events at these 98 locations, largely weighted to the east and west coast. But as a nation, we're rapidly increasing and in fact have doubled. Sort of the trend there is the high tide flood frequency rate is double of what it was just 20 years ago. Because of sea level rise, the risk of flooding due to high tide are twice of what it used to be 20 years ago. And that's really, that's less than a mortgage cycle. So when we look at these individual locations, the one in reds have these annual high tide flood rates that are accelerating. Where they are yellow, it means they're sort of linearly increasing, likely soon to be accelerating in a few more years or another decade or so. They all will eventually get that way. So right now we have over 40 locations accelerating. So that's, again, if you're in one of these areas, it's not to, impress some doom and gloom kind of situation, but it's important to recognize what the data is showing so that these communities have this information and plan and prepare for a floodier future. That future is here. It's now. It's the rates have doubled nationally over the last 20 years, and it's not an end of the century kind of discussion any longer. It's sea level rise impacts happening now. So in terms of seasonality, so now we sort of track trends, we score kept. When do these events typically happen and why? And here's an example of water levels in both Norfolk and San Diego. And in this case, you can kind of get a sense of the tides were in blue and the observations are in red. And you can kind of get a sense that, the tides aren't as significant in Norfolk as they are in San Diego. The green would be the local high tide flood threshold. So when you flood in San Diego, you're typically because you're at a sort of a full moon or a seasonal high tide. Whereas in Norfolk, that's not the case. So these king tide kind of calendars or, go out and take pictures, these initiatives are probably a pretty good idea in areas where the tides are the dominant signal. But in areas like Norfolk, you may or may not hit a flooding situation during your high tide because the tides are aren't that big and they're not that impactful, let's say, as compared to weather. And so we can get a sense of where around the country that is the case. So Norfolk is more of a weather-driven situation right now, whereas somewhere like San Diego is a really tidally driven location. And we can get sort of a sense with these same sort of ratios. There was an earlier paper that described this around the country. Where are you more weather-driven or tide-driven? So really it reflects sort of your tide range, but it also reflects the fact that, let's say the West Coast, at least the southern West Coast, you just don't really have much storm surge. The winds can blow, you can have a really violent storm and the wind's really strong, but you just don't get much surge. Whereas on the East Coast you do, so that's another factor in play. But this is sort of a way of getting a sense of, when you are going to flood, why are you going to flood? And what predictive tools do you have? Is it high tide predictions themselves, or is it more of a weather phenomena that you need to pay attention a few days beforehand? From that, we can also look at peak season. So what's your high tide flood season? So typically within a year, they're concentrated within some places more than others within a certain season. So on the West Coast, it's really more of this winter. Both you have more winter storms, but also during the solstices, during the spring tides, the seasonal high tides, they're amplified. And so typically your Decembers and Januaries around the spring tides there, when you flood, it's more often during that time. You do also get flooding at your summer solstice as well. On the East Coast, it's largely in the fall. Your mean sea level cycle has about upwards of a 1 foot cycle that's built into our tide predictions. So water levels are just higher, let's say in the late summer, earlier fall, but that's also when you get change of seasons. You get a lot of wind and it could be hurricanes, but again, those are relatively rare compared to just winds blowing offshore. There are a few areas in New England where it's winter storm and a tide phenomena, and a few places in green where we have tide gauges up rivers where it's more of a spring river effect. In terms of actual sort of predictive seasonal skill with sort of dynamically driven guidance, we are currently working with that with some collaboration via Oceanic Atmospheric Research arm of NOAA and the Climate Program Office, CPO. Apologize all the acronyms, as well as some of the cooperative institutes are receiving some funding currently. The Earth System Research Lab out in Boulder, University of Hawaii, University of Miami, Kent State, to name a few. So hopefully in the near future, we'll have more than just the high tide calendar. We'll actually have some guidance to tack onto the tides as well to give some indication if this season's going to be floodier than otherwise expected. And, the days that you should actually look at the expect that might be high tides or might not. We do have a new product at CO-OPS at National Ocean Service. It's the High Tide Bulletin. It's been out for a few years, but it's really starting to get a little bit more attention lately as these flooding events increase in frequency. It's really alerting to the times of king tides, let's say, the atmosphere or the astronomic tide itself. When are your highest tides likely to be, and regionally where are they likely to be more impactful than others? And again, we hope to couple this with some ongoing research to really bolster this product so we can give sort of that seasonal readiness alerts for communities so they know really when to prepare for these floods. So now getting on to annual projections, how are we making these next year outlooks? A lot of it is really based on both sea level rise and the trends associated with that, baked into the high tide flood counts per year. And also we're leaning on El Nino and La Nina characterization, since that's an operationally tracked and projected phenomena by NOAA and partners. So on the West Coast during an El Nino, you really get higher water levels, oftentimes for months at a time. It's a deeper thermocline, warmer water. It has other implications for fisheries, but the waters are higher, and your tides and storms, when they occur, are just riding over higher water levels. During a real strong El Nino, you might get a couple decades worth of sea level rise within a year. On the East Coast, it's a slightly different phenomena. It's more of a weather, sort of teleconnected wind effect. You get two sort of phenomena that occur, one of which you get more of a northwesterly wind forcing in the northern sort of New England area, more so than the westerlies, which tend to drive a bit of a sea level anomaly against the East Coast, as well as a storm track that's more coastally oriented along the East Coast. So you have more storminess, more storm counts. So a combination of the two tend to manifest during these El Nino, and particularly the stronger El Nino. And so when we look at that historically, what we're showing here is Norfolk and San Diego. The black dots would represent the number of high tide flood days per year. And you can fit either, in this case, a quadratic through both of them now are statistically significant, would be the black line. And the black sort of shaded projection would be if you just considered sort of the trend in high tide flooding events themselves, plus or minus one standard deviation of that regression line would give you that outlook for the next year. But you can better characterize the past through considering the Oceanic Nino Index, or what was the state of El Nino and La Nina. So when you do that in sort of a bivariate type regression, it improves the overall characterization, and at least in a hindcast skill sense, you get closer, and those would be the red dots of what that regression would look like if you considered the El Nino state. And so next year, at least when we made the outlook, the mild El Nino is predicted to persist. Now it's looking like maybe it might start to break down some, but when the prediction was made in May or so, that was factored in, and so you get this in red is what if there is an El Nino sensitivity, we'll factor it in, and that would be sort of the basis of the outlook, let's say, for Norfolk and San Diego. And so we can look around the country where El Nino, in this case, solely affects the high tide flood rates in a statistically significant manner. So it's both really a West and East Coast phenomenon. So when we start talking about El Nino, it's important not only to discuss changes in precipitation and temperature or snowfall, but it's also a coastal flood issue. And so these areas will have this El Nino factor baked into their outlook. And so here is the actual outlook. We provide a range. Here we're actually showing an actual number because we have to map it. But again, it's these rates are increasing. They're very different than they were just a decade ago, and that's why we're actually tracking at both the sea level rise and climate variability associated with El Nino and La Nina. So communities can plan and prepare, and there's a cost to shutting down streets, and having that information we're understanding from several of these communities is useful in their preparations and budgeting purposes. And here would just be an example of next year's outlook relative to what the trends would have been in year 2000. So, upwards of 100 to 200% increases in a lot of these areas. So if you're projected to have, let's say, 10 to 15 next year, in 2000, you're likely having about 5 on average. That would be the case for Norfolk. So again, it's a very noticeable change, and it really overlaps to what the communities and longtime residents will testify to. And we have a new product at NOAA NOS that is actually now online, that you can actually get these outlooks, and you can hover over location and actually get what the outlook would be. Here's Washington, D.C. It will recap what happened last year, and in this case, it broke a record. Some of it was a rainfall driven signal within the Washington, D.C. Potomac River gauge. And I'll talk about the future 2030 and 2050 projections. But this is, again, a sort of a graphical web-based product now where you can actually get these outlooks, so communities can really go to their location and get a sense of what they may expect to experience next year. So in the last part of the talk will be what to expect in the future. We know it's changing. It's been changing the last several decades. Next year is expected to be different than last year, very different than it was 2 decades ago. So how about 10 years from now or 30 years from now? A mortgage cycle, perhaps. I just bought a home in Annapolis, so luckily I did due diligence. Our house is actually quite high above water level, and then partially that's due to topography. But again, these are the kind of decisions that not only companies are making in terms of where are they investing and what is their asset exposure, but also people. It's largely flooding is a people problem. We live near the coast and we build near the coast, and it's something that we all need to understand, that flood risk is not uniform across the coastal floodplain. And so having this information, at least in terms of high tide flooding, is a useful tool for people to make decisions about how they want to live at the coast. So where is sea level going? Black is sort of the historical reconstruction of sea level. The purple or pink here is sort of the overlay of what the altimeters have sensed. And these 6 scenarios are possible outcomes. The higher outcomes are less likely. The lower outcomes are more likely. And this is a global average rise. So somewhere from a continuation of the current rate of 3 millimeters a year or an inch every 8 years up to some very disturbing numbers of over 2 meters. Very unlikely to occur, but it's not it's plausible that they could occur, and if not 2100, then later. There are folks that need this information. They're called risk managers, and oftentimes it may be associated with the military. If you have something that can't fail, well, then think about situations where if they did fail, what would happen, and what do you need to be prepared for, and what's your risk tolerance? But we will focus on the and here we're really going to focus on these 2 particular scenarios, which are the more likely. In this case, the low end of a likely range, statistically speaking, sort of plus and minus a standard deviation. This would be a low and -1 standard deviation from the expected under a reduced emissions pathway of, these are called representative concentration pathways, and more or less greenhouse gas emissions and resultant heating, more or less. As well as the high end under 8.5, which would be the sort of the continuation of business as normal that we're on now. So we'll consider these the more likely outcomes. And we'll frame the rest of the discussion using these 2. So here's what it looks like on a global basis, and we actually went out to year 2200. We did this with interagency colleagues through a NOAA report that was actually fed into the 4th National Climate Assessment. So somewhere by 2100 of about 0.5 and 1 meter rise, and again, it continues on past 2100. It's not like it's a hard stop at that point, even though oftentimes we discuss it at that point. Locally, there will be reasons why you'll be above or below the national or global average, and we've gridded these on a 1 degree gridded basis for the U.S. coastline. The three main reasons would be, well, vertical land motion are used subsiding, which most of the East Coast is and much of the Gulf Coast is. Ocean circulation changes. If the Gulf Stream slows down, which it does, but it also speeds back up this variability, it raises sea level along the East Coast, and all the models suggest that in a warming ocean environment that the Gulf Stream or the overturning circulation in the Atlantic will slow down. And that'll exacerbate sea level rise even further along the East Coast. And the third, which is a little less intuitive, is how gravity and the rotational effects of the Earth itself will change due to redistribution of ice that are locked up in these large ice masses of Antarctica and Greenland and these mountain glaciers. As they melt and contribute to the global rise, they'll also cause these sort of static or these just apparent changes in the actual ocean. There'll be higher, Antarctica, for instance, will cause more sea level rise along the East Coast. So where ice melts matters. And again, we'll focus sort of on these more likely outcomes. But what we can see here on the color scale, if you're at 1, means you're very close to the global rise average of the scenario of 0.5 meters or 1 meter. But if you're sort of more in the orange or red, you're 1.5, you're 50% or even twice that rate, which you see in areas of where there's a lot of subsidence due to fresh water and fossil fuel extraction. On the East Coast, it's maybe some natural regions, some glacial isostatic adjustment. But if you're planning on a global rise, let's say of 1 meter, you might need to be planning on a local rise of 1.5 meters. So again, we're doing this so all communities can have sort of this consistent, authoritative information based on best science at the time, and this will be updated on a regular basis as the science and the data and the models improve or change. So here would be sort of a blow up again of this more localized expression of the global scenarios. There is the NOAA Sea Level Rise Viewer Group has modeled now what these actual local scenarios will actually look like at a location. You can click and get a sense of how much rise under various scenarios will occur. And so then you can actually look at the mapped areas to see those that this would be the high tide line. This wouldn't be the high tide flood frequency line. This would just now where high tide is literally hitting every other day. So, you know, change will have long occurred before this happens, but it will get a sense of vulnerability or at least exposure. So this is what these likely sea level rise scenarios themselves look like, overlaid with the tide gauge measurements. And these scenarios have this vertical land motion built in. So we're tracking this at NOAA now, so you can get a sense of sort of, at least at this point, you know, some sense of the trajectory or at least interannual variability. How's it stacking up to the future trajectories themselves? So, you know, some areas it's a little bit higher, some areas it's a little bit lower, but in terms of risk framing for sort of a common usage, you know, this is what, you know, is likely to unfold over the coming century. So in response, how might high tide flooding itself change? And so what we show here is at Charleston, at this flood threshold that really does equate to water in the streets. It's actually about a half foot higher than the actual minor flood threshold that the Weather Service uses. So it really is a problem when water gets to these gets to that height and this frequency. And this would be a projection under those two scenarios. So again, it's a much floodier future, but again, that future is here now. It's, you know, it's already rapidly increasing, and it's expected to do the same as that sort of probability distribution, or the typical tides and typical storms become increasingly impactful. And so now what might be more of a result of a wind event or a partial, some storm, some tides, in the future it's largely tidally driven. And so we're really not trying to provide, any particular year guidance in the future. Really, these scenarios of sea level themselves, as well as the high tide frequencies, really should be probably on an annual basis, but average over the decade. We're not really trying to pick any particular year. And so this would be historically that same sort of historical bend and average per decade annually, but on average per decade, what you would expect. And this would be sort of a projection into the future. Again, the y-axis here of days per year is now on a log scale, so it's really sort of this exponential increase. We do have a NOAA product out of the Climate Resilience Toolkit. supported by the Climate Program Office that is also ingesting this information so communities can get a sense of these two outcomes of the sort of the likely futures that are in store. As well as our same tool that I showed earlier, you have a tab, you can go to 2030 or 2050, and in this case, you can actually hover over a location and get sort of that range of between 50 and 150 days, for instance, at Norfolk by 2050 or thereabouts. So again, it's a little bit uncertain. One thing is certain, emissions matter. CO2 levels do affect the projections of sea level rise. Less CO2 equals less warming equals less sea level rise equals less high tide flooding. But those are largely conditional upon a future that we don't know is going to occur, and so we provide that range. The outlooks for next year are more based on variability and what's already happened, whereas as we project a couple decades in the future, there's an outcome that's somewhat uncertain, but at least it allows a bounding for some actionable decisions to be made. So in closing, we'll take questions here in a minute. Here are some of the products that were discussed today. So I don't have the hyperlinks here, but you can actually just Google and you'll find them to explore around and get a sense of what's useful and what's not. And we'd love to solicit feedback through the various outreach groups that are at NOS to improve these products. And some of the reports that I pulled from that underpin many of these products can be found here as well. So that's it, and with that, we'll take questions.
So Billy, on the chat there, we have, I think the first one is the Sydney Fisherman at the top. If you see that, have the NOAA SLR viewer HTF maps and ground truth in any areas. We'll start with that one.
All right, which one is this? Where are we?
Scroll up a little bit. It's at the very top.
Okay.
Right there.
What fraction of the coastline flooders?
The one above it.
Okay, have the sea level viewer high tide flood maps been ground truthed in any areas? Well, that's a great question. Ground truthing is really somewhat empirical and anecdotal. It's elevations that are at risk. It doesn't mean everything is going to flood. There have been lots of communication and discussion amongst the Office of Coastal Management. Actually has a lot of people in the field, as do the weather forecasting offices. And they really do align pretty well with areas that are flooding, that tend to flood, really do align fairly well within those regions within the red elevations that are flagged at being at or below the high tide flood elevations. But more can be done, and a lot of this is sort of through the citizen science, photo taking initiatives to really document where is flooding occur. It's a hard thing to really spatially assess. But with technology changing, we all have smartphones that have lat long, and we have geoid models that are developed by the National Geodetic Survey here in the Ocean Service. So I don't think it'll be long before we really start to composite and inventory and start generating these catalogs of where impacts are happening. Because one thing does repeat, if it's recurrent flooding, typically they're recurrent impacts. I would say yes, they are sort of calibrated to some extent, though more could be done.
Any questions in the room?
I want to ask a follow-up question about what are the citizen science projects that you're referring to? Do you know the names of them or?
A lot of them are the King Tide initiatives.
Okay.
And so if you Google that, you can, again, not to just call out Google, if you search for that, a lot of them will pop up. And some are in conjunction with NOAA. The communication and education groups have been involved in a lot of the citizen science, as well as some of the National Ocean Service themselves through Sea Grant and RESAs. There are initiatives that are in conjunction, though the archiving of these photos, I think, is important. They're important not only to ground truth, like street level flood maps and models of where flooding is actually occurring, but right now it's largely a collection sort of community-based effort.
I highlighted that one from Steve.
What fraction of coastline flood risk is due to development versus water rise? Well, that's a great question. So, we're at risk largely because of development, right? If a marsh floods, is it flooding? I mean, I guess it is, and eventually have a long-term consequence of, ecosystem change and salinity and what have you. But, flooding is really flooding because it's a problem that we're in the way of the water and tide's way. So it is a hard percentage to come down and say, what part of this is development. But one thing is our tide gauges are really situated, they really sort of affect more the ocean level, not so much rain, or there's a few that get riverine effects, but largely we're not in these major rivers, we're in harbors, so rains and river and waves really aren't bleeding into our signal. It's really more of the surge and sort of still sort of water that is there through the tidal cycle or through a multi-hour kind of surge event. So you're not necessarily sensing the urban runoff effect, but the urban environment is also providing conduits for water to get where it typically wouldn't. Stormwater systems, water will follow that and they will come up through these systems into the street. So there is an important factor is how we've developed and where we actually allow water to flow is part of the problem.
Any other questions in the room? All right, so we have one from Susan Love here.
Is there a place where we can directly access some of the great info, the peak season, acceleration or no tide weather for each of our current tide gauges? So yes, Susan, that information is in a 2018 report there, the NOAA patterns and projections of high tide flooding along U.S. coastlines using a common impact threshold. I kind of truncated the title. That's on our co-ops website, and that really goes into depth. Currently, we don't have that all scripted into products, though we're headed that way. And please feel free to email if you like more information or some of the actual data sets themselves.
She had a first question, Bill,
Oh.
highlighted.
First question.
How do you determine whether a site is accelerating?
You determine that just statistically does a quadratic, is it 90% at the 90% significant level? And if it is, then it's accelerating. So it's pretty much straightforward sort of geometry and curve fitting at that point. If it's not quadratic, then maybe it's linear, and then we test for that. So in all cases, it is at least at the 90% or 90% confidence level.
From Steve, we have for weather causes for high tide, did you include the wave run-up from high surf?
No, we did not, Steve. That's a good question. So, on the West Coast and islands in particular, it's really the waves really cause a lot of the actual observed flooding or erosion or coastal hazards. The USGS has been working with NOAA to actually incorporate that within their forecasts of run-up on the East Coast. So you can really get a sense of it's just not high water or surge, but it may be the waves that are really causing the problems, overtopping seawalls or causing erosion and bluff collapse. That's something we'd like to work on maybe in the West Coast to incorporate sort of a more of a dynamic threshold. The Weather Service, though, do have thresholds with waves in particular areas where waves are problematic. They'll incorporate that within their warning criteria themselves. So something to be further explored.
And what fraction of global ice must melt into the ocean for the red scenario to happen?
The red scenario, I believe, was the extreme 2100, 2.5 meters. There would have to be a significant contribution. You can actually go in the Climate Science Special Report, was the last one of the papers there. We talk about, in the past at least, the fraction of Greenland and Antarctica that contributed to sea levels of very upwards of 5 to 10 meters higher than today, with similar temperature and CO2 levels. 125,000 years ago, a little bit less as to a couple million years ago, possibly more, less constrained then. So it's something that is very unlikely by 2100, but when we go out to 2200, even the sort of the upper end of the likely really starts to get into those higher numbers. So, these instability of these ice sheets right now are sort of in the literature right now being discussed. At what point are we likely to destabilize, and are some of them already destable? And they would likely, could have some very rapid onset of flooding. When, it's not really sure. But one thing is certain is that there's a sort of a longer term momentum being baked in right now with the amount of heating that's going into the ocean. A large percentage of the atmospheric warming is the heat's being absorbed by the ocean. So there's a thermal memory here, and so sea level is not stopping at 2100, and it's very likely not stopping for the next several hundreds of years, with levels getting to that 2.5 meter, if not very unlikely by the end of this century, but much more likely by the end of next.
So we have one here. Do you have suggestions for management strategies to address these increased high tides for local communities and cities?
Well, one management strategy is, I think it's important that people get flood insurance if they don't have flood insurance. I'm not sure that's necessarily going to be the strategy. I think there's two things here. One is recognizing that emissions matter. Collectively, things can be done to minimize the overall risk moving forward. Locally, that may be, unobtainable. What's going to happen is going to happen. But using the NOAA data and sciences to really understand your risk now, to then, project forward the next, couple decades to understand what your risk is likely to be, so that the decisions can be made local as to how to address this, whether it's to, start to actively pump water out of the streets. Like in Charleston, they're actually installing some different drainage type systems to deal with water. Maybe it's, living green shorelines, to recognizing you need maybe some areas to beef up your actual seawalls, or, that would be fight against both storm surge and high tide flooding, but it still allows some, recreational usages at the coast. So there are a host of solutions that can be made, and our Office of Coastal Management largely addresses these and works with communities to understand, pathways forward. But I think primarily the original sets of data that we're collecting at these tide gauges are really alert, how flood risk is changing, what it's likely to be, so that those decisions can be, based off sound science, and plan for a floodier future.
Is there one threshold or built-in limit that cities and communities are using as their conservative method to do all their planning, or there's not one?
Yeah, there's one threshold doesn't fit all, and that's really the case. And it really comes down to an elevation game. Within the, let's say the FEMA's base flood elevation, where you either should have flood insurance or don't, flood risk is not the same. And when it comes to tidal flooding, it really is more of a bathtub. You're not going to hold back the tides. You can build storm surge barriers to help prevent, like, short instantaneous rises of water. They're talking about doing this in Galveston and New York City and Boston, but you're not going to hold back the tides. So, what threshold, right now, at least for building standards, there's more discussion at the 500-year event, or, an annual chance of, very rare, but becoming, more likely as sea level rises. That's a good start. But again, it's hard to defend against infrastructure that's at ground level or subsurface. Your storm waters, your wastewaters, your fresh waters, your buried cables, your roadways. You can't backfill and build walls everywhere. So, moving forward, it's an elevation game, and that's sort of what's important to recognize in conjunction with the flood frequencies that we're measuring at these tide gauges. It's sort of a balance between what's your elevation and what's your current risk, because the risk isn't the same everywhere at the same elevation.
Okay, here's one from Renee, where the Climate Explorer is showing the high tide flood frequencies under different sea level rise scenarios. Is that based on the standard threshold from the SWEET 2018 paper, or are those based on the local WFO thresholds?
I feel like I fielded a question from Renee once before on this. Good question, Renee. Originally, we started out with actual WFO thresholds, and there could be still a relic page in the Climate Resilience Toolkit that shows that, but now under the Data Explorer, they're all using these new thresholds. And the reason we went to the new thresholds is, again, to try to really do this regional and national comparison. As in anything, that the threshold matters, but it's really the flood count that people are going to gravitate to. And by using the lower thresholds that exist, let's say currently still in places like Wilmington, North Carolina, Annapolis, Maryland, Washington, D.C., using the old thresholds, which are not the old, but we'll say the WFO Weather Service thresholds, not say they're incorrect, they're really there to provide a flood risk categorization that's important for them for alerting the public. But you have, contextually, you would have tide gauges that might hit this 50, 60 times a year, and it doesn't necessarily equate to what people see. Now, that's not the role of the Weather Service in that, but again, in our usages of the Ocean Service, we really kind of want to have, the same type of level severity from place to place. So I think the Data Explorer now, in the short answer, are all using these sort of this nationally consistent tide range based threshold estimate.
Any other questions in the room? Okay, so we have from Don, at the coast, the FEMA flood elevations do not adequately represent the flood risk. Any efforts to bring these signs into FEMA methods?
That's a great question, Don. I think I'm curious how this actually will unfold. We haven't really been directly working with FEMA, at least under these lesser extreme types of events, but I am curious how, the flood insurance program will start to recognize that, these recurrent floods become more and more frequent. At what point are they no longer named storms or these extreme storms, which I think the original intent of this flood insurance program was to help defend and make it viable for businesses and people to live at the coast with some degree of consistency, that they will be able to maintain their lifestyles and commerce and what have you. But as sea level rise really starts to increase the probability of the whole spectrum of floods, that's really something that I think as a nation we're going to have to come to accept the fact that sea level rise impacts are happening here and now. The risk nationally of high tide flooding has doubled in the last 20 years. The 20-year events are now 10-year events or 5-year events. So, it's a very good question. I've got no answers, but it's something I think we're really trying to raise the attention that sea level rise isn't a long-term esoteric type of discussion. It's not a 21-year, 100 issue. It's an issue now.
So, Bill, you have a lot of thanks for the presentation. Sarah, she works with the North Carolina King Tides Project. Wanted you to know that. North Carolina Sea Grant, North Carolina Sentinel Site Cooperative. There is one. We have about 1 minute left. Probably this last question. Are there any tide gauges excluded from this analysis?
Yes, there are some tide gauges excluded. What are included, maybe is an easier way to say it, is we included all tide gauges with at least 20 years of hourly record. However, and this was written about in the 2018 report patterns and projections, we excluded those that have tide ranges over 4 meters, which is very few in the lower 48. There are more of those in Alaska. We also did not include Alaska. From our sense of working with the weather forecast offices, they build quite resilient because they're used to all sorts of storms and hazards, and that really, if something happens, no one's there to help you to begin with. Sort of saying this loosely, but it's a tricky problem. And the other phenomena is where sea level is actually dropping. So in the historical context, as sea levels drop, then looking backwards, you would say that these events happen more frequently in the past when they may or may not have, but in an intuitive sense, it didn't really make sense. So in essence, we did exclude those with tide ranges over 4 meters where sea level is actually dropping, largely in Alaska and in areas in Alaska itself.
Okay, so we're at time. There's a few more questions that are left. So are you okay if people email you those questions? Okay,
Sure. Sure. Love taking email questions.
All right, thanks everybody for coming today. I really appreciate it. Thank you, Billy, for
Great.
coming today.
Thank you. User services.